Hello and welcome to my Pre-Algebra review series. This video covers Chapter 10, Section 9, titled Volume, Pyramids, Cones, and Spheres. By the end of this video, you will have reviewed recent lessons regarding finding the volumes of cones and pyramids. We will end this review by looking at a real-world problem to find the volume of a sphere. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It'll be more than likely help them, and it certainly will help this channel to be seen by more students. If you would like me to cover any of these topics in greater detail, please leave a comment here in the comment section below. I read them and do my best to address each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. Objective 1. Find volumes of cones and pyramids. You can fill 3 cones with sand and pour the contents into a cylinder of the same height and radius. You will fill the cylinder evenly to the top. So what is that saying? That says you have 3 cones. Here are the 3 cones. Cone 1, cone 2, and cone 3. And I'm going to change the color. Let's go to this blue. And cone 3. And here's the cylinder over here, the cylinder. If you take and fill all 3 of these cones to the top with sand, let's say, and the area of this cone, you have the area of the circle here at the bottom, and you know how we determine the area of the cone. And here's the area of this cylinder with the same radius, and the height h is the same height as the cone. You can put 3 of these cones into the cylinder, and it'll fill it right to the top. The volume of the cone is 1/3 the volume of a cylinder. So remember that. The cylinder is base times height, and the area of a cone is, down here, 1/3 the base times the height. So the concept here is, and I should say the relationship is true for pyramids and prisms with the same base and height. So if you have a pyramid and a prism with the same base and height, you're going to be able to get the same relationship of 1/3 the base times the height. So the volume of a cone or a pyramid, in the key concepts, the volume V of a cone or a pyramid is 1/3 the product of the base area B and the height H. And so we're looking at these little pictures down here. They're showing that the base and the height, okay? That's how we're measuring the area, 1/3 the base times the height. Example 1, finding the volume of a cone. Find the volume of a cone. Here's the cone on the right. It has a 3-foot radius, and it's 10 feet high. You can see that. 3 foot, the 3 right over here. Here's the 3 feet, and here's the radius right here. And it's 10 feet high. You see the height coming right out, dropping right out of this vertex of the cone, the tip of the cone, right down to the center of the circle. So the volume is 1/3 base times height. That's the formula for the volume. 1/3 pi r squared h. 1/3 pi r squared h. Pi r squared is the area of the circle. Okay, so it's the area of the circle times the height times 1/3. Where it says b is the area of the base, pi r squared. So we get 1/3 times 3.14 times 3 squared times 10. So you replace r with 3 and h with a 10, and you come out to 94.2. If you add them all up, you get 94.2, and it's feet, right? I'm going to go over here. It's going to be feet cubed. Volume of the cone is about 94 feet cubed. Okay, example 1, check your understanding. Find the volume to the nearest cubic unit of a cone with a height 5 centimeters and a radius of the base of 2 centimeters. Go ahead and do it. When you come back, we'll work it together. Okay, now that you're back, let's do this. First thing I'm going to do is let's just draw a cone. Let's look at what we're looking at. I'm going to draw a cone. See how I'll draw a little V here. Okay. And then I'm going to draw kind of a circle. Not too bad. And then I'm going to draw this dashed line down the middle, which is the height of our cone. It goes right to the center of the circle. The radius comes out from the center, and this is the height, right? From here to here. So the height is, it says 5 centimeters, and the radius is 2 centimeters. And that's our cone. So now we go over here and do the volume of a cone. The volume of a cone, V sub C, okay, is equal to 1/3 the base times the height. V sub C is equal, oh, I said 1/2 right there, but it's 1/3. 1/3, the base is pi r squared. Pi r squared times the height. To the next line. V of the cone, the volume of the cone, is 1/3 times 3.14 times 2 squared times 5. We replaced the h with the 5, and we've replaced the r with the 2 centimeters, 2. So now we get V of the cone is 1/3 times 3.14 times 2 squared is 4 times 5. So if we carry this math out, we're going to get V of the cube is equal to 21 centimeters. What? That's right, cubed. Make sure you always take care of your units. Okay? So that is the volume to the nearest cubic. It's rounded because it normally would be a little higher, a little lower. I'm not sure which one it was when we did the math. I did the math ahead of time. Anyways, there it is. 21 cubic centimeters. Okay, example 2, finding the volume of a pyramid. Again, find the volume of a square pyramid. This is a square pyramid, and they're telling us it's a square pyramid. We see it's square pyramid. And we look at the bottom down here, it's square, right? Square goes like this, and then it goes across here, and it goes. It's a square pyramid. It has 4 triangular sides that come up and meet at right up there at the point. Okay, so we know the volume is 1/3 base times height, just like the cone. The volume 1/3 S2. It's 2 sides, right? The volume, it's 6 times 6. So they're saying S squared. S squared times the height. 1/3 6 squared times 10. We replace the S for the side of the box down here, the square, with 6, and we squared it, and the height is 10 feet. So when you multiply this up, we're going to get 120. They didn't care here, but I'm just going to write it in anyways. Feet what? Feet cubed. And here it is. The volume of the pyramid is 120 feet cubed. Okay, example 2. Check your understanding. Find the volume of a square pyramid with side of 5 feet and a height of 20 feet. Well, it's a square pyramid, so the side meant the sides of the square, right? Just like we did in the last one. So you go ahead and do it, and when we get back, we'll do it together. Okay, I'm assuming you took your time and you did it. So let's do it. So first of all, they want me to draw a square pyramid. So I'm going to draw a square over here. And I'm not sure I can draw the pyramid with all lines, but I know one gets a point up here, right? And then this one comes up to here to the point. And then in the back here, there's one coming up to the point, and then there's one in here, right? And then we got this dashed line comes down to the base, right down here, okay? And that this side length is 5 feet. So that means this side length is 5 feet. And the overall height of this pyramid is 20 feet, okay? So let's solve it. The volume of a pyramid, P, is equal to 1/3 the base times the height. Okay? The volume P, the volume of the pyramid, is equal to 1/3 times, and what is the base? It's S, or 5 squared. 5 times 5 times 20. We replace the H with the 20 and the R with the 5 in this formula. And because a square is, or rectangle is one side times the other side, the length times the width. And that's a square, so they're identical, so we can square it. So now we have these. So we can say the volume of the pyramid is equal to 1/3. 5 squared is 25 times 20. So 25 times 2 is 50, times 10 is 500, 1/3 of 500. So the volume of the P of the pyramid is 500 divided by 3, and that equals 167 feet cubed. Okay? And you see what I did with the 1/3? I just wrote it out, put the 3 under the 500. Okay? There's your answer to that one. Objective 2, finding volumes of spheres. The key concept here, the volume of a sphere. The volume V of a sphere with radius r, they're showing that sphere and radius r right there, is 4/3 pi times the cube of the radius. Okay? That's the volume of the sphere. 4/3 pi times the cube of the radius. So you see that cube is right. We haven't seen this before. Here we're cubing the radius. We've squared it before. We've used it by itself, but now we're actually radius times radius times radius. And it's pi r cubed. 4/3 pi r cubed. Let's look at it further. So example 3. It's a real world problem. It's a tough one too. We got a snowman smiling at us. Snow spheres. Okay, a snow sphere. You build a snow structure with snow spheres. What is the volume of the snow in the bottom of the snow in the bottom sphere? How much snow is in the bottom sphere? Well, what do we know is what we know is the formula for the volume of a sphere is 4/3 pi r cubed. Remember that. Using the formula. So let's fill it in. It's approximately. They're saying approximately here because we were using pi. We're going to substitute right here for pi 3.14. So 4/3 times 3.14 times 1.5, because the radius, the diameter of this sphere is 3 feet. Half of it is 1.5 feet cubed. Okay, replace r with 1.5. When you do that and you multiply it all out, and I don't have a calculator to do it here, I could stop, but I've done it already. The answer to that is 14.13 what? Cubic feet cubed. That's the volume of that sphere. So the volume of the bottom snow sphere is about, and it is again about because we're using pi, a representation for pi, not the exact pi. It's about 14 feet cubed. Example 3, checking your understanding. Directions. Find the volume of each sphere to the nearest whole number. Okay, there's 2 spheres we're going to do here, or you're going to do them right now. You're going to go off and do them yourself. And then when you come back, we'll try to do them and see what answers we come up with. Okay, now that you're back, let's start with A. So A says 15 meters is the radius. Okay, so let's say the volume of the sphere, volume of sub S, is 4/3, remember that? 4/3, what? Pi r cubed. Remember the cubed on this one. So the volume of the sphere is equal to 4/3 times pi 3.14. I'll put parentheses around that. Times r. which is 15 cubed. So if we take our calculator and run it out, I'm not going to stop. I don't have a calculator handy. I've already done the math. We know that the volume of the sphere is equal to 14,130 meters cubed. That's 4 times 3.14 times 15 cubed, which is a pretty large number. Okay, then divided by 3. There's your answer, 14,130 meters cubed. The next one, problem B, says that our diameter now is 7 miles. So what do we have? We have a volume of this sphere is equal to the formula, 4/3 pi r cubed. Okay, so the volume of our sphere is equal to 4/3 pi, which is 3.14, times r cubed, and r is 1/2 of 7, because this is the diameter, so it's 3.5, 3.5, I'll put parentheses around this, cubed. So 4/3 times that times, 4/3 times pi, which is 3.14, times 3.5 cubed, again, comes out to 180 miles cubed. We could do the math with a calculator. I know you have a calculator. You can do the same thing, and you'll come up with 180. You're going to round that number. Whatever the number came out to, we're rounding it to 180 because they want it to the what? To the nearest whole number. Okay. Good job on this section.